All right, in this section we're going to extend our knowledge of inequalities to include what are called conjunctions and disjunctions. So basically inequalities that involve the word and inequalities that involve the word or. So we just got done talking about basic inequalities, so now we need to look at inequalities that are a little bit more complicated. So here's why we need to do this. So in the previous section we talked about if you wanted all numbers greater than or equal to 10, that was no big deal. We could do that on a number line with a closed dot on 10 and then shade all the numbers to the right. And then as an inequality, it was just all real x that are greater than or equal to 10. But what if you only wanted the real numbers between 0 and 4, including 0 and 4? How would you write that as an inequality? Or how would you write an inequality that describes all the real numbers less than -1 or equal to -1, and then all the real numbers that are bigger than 1/2? So we need to talk about how to write more complicated inequalities such as these two right here. These are just examples. Those are not the only two sets of numbers we want to describe. So we'll start with some vocab. So a conjunction is a sentence formed by joining two sentences with the word and. And a conjunction, the entire conjunction will be true when both of the smaller sentences are true. So remember what a conjunction is. It's one big sentence that's formed by taking two smaller sentences and joining them with the word and. So if you want the entire conjunction to be true, both of the smaller sentences must be true. So for example, let's graph the conjunction x is greater than -2 and x is less than 3. So if we graph that, we need a number line. And we need -2 and +3 on there. So if this is 0, let's have that be 1, 2, 3. And then we need -2. So -1, -2. So this is every x value. And we want x greater than -2. So we don't want it to be equal to -2, so open dot. And then we want greater than, so this direction. But we also want less than 3. So less than 3, here's 3. We don't want to include 3, we want less than 3. But this conjunction is only true when both of these are true. In other words, it's only the x values that are bigger than -2, but also, at the same time, less than 3. So one way you could think of that is these were all the numbers bigger than 2, and then these were all the numbers less than 3. So visually, we'd be talking about where the two overlap each other. So they overlap each other right here. So they overlap each other. I'll do it in red. They overlap each other right there. So on the number line, it would be all the numbers between -2 and 3, but not including -2 and 3 because we didn't have equal in there. So typically we would write that as, since it's between, since we have a between situation, so it'd be any number between -2 and 3, we'd write it like this. So it'd be all x such that x is between -2 and +3. That would be the solution set. So x is bigger than -2 but smaller than 3. So verbally, this would be any real number between -2 and +3. So this would be a visual representation of that conjunction. This would be the solution set, and then this would be a verbal representation. Well, what about the other type? A disjunction. So that's a sentence formed by joining two smaller sentences with the word or. So a disjunction is true when at least one of the smaller sentences is true. So for a disjunction, we only need one or the other to be true. And it's okay if both are true. That's not a problem. We just need at least one of the two sentences to be true. So for example, if we're asked to graph the disjunction y is less than or equal to 3, or y is greater than 7 halves, well, we need a number line. And we need to get up to, what, 3.5, and from 3. So we just want to make sure we have a scale that's appropriate. So if we do, say, 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. And we don't need the rest of this. Okay, so we want y to be less than or equal to 3. So you 3, so we want a closed. And then we want less than or equal. So all of those numbers are okay. And we want y greater than 7 halves. So 7 halves would be 3.5. So greater than, all of those would be okay. So if this is every single y value possible, any of the numbers less than or equal to 3 would solve this, or any number bigger than 7 halves would solve this. So there's actually only a small portion of the number line that would not solve this. So its solution set would be y such that y is less than or equal to 3, or y is greater than 7 halves. There is no between. The numbers are not between two different numbers. So it's not like the and, where we can write it where you have the variable between two numbers. We have to actually use the word or. So verbally, this would be any real number less than or equal to 3, or greater than 7 halves. So there are some numbers that don't work. Like if you pick something bigger than 3 but smaller than 7 halves, that would not work. So any of the numbers in this area right here, those don't work. So these are not solutions in here. Okay, so there are some, in this particular one, there are some values of y that would not solve that inequality, that disjunction. All right, so let's actually do some complicated ones, just so you can see what we mainly will be doing. So we've been asked to solve and then graph the solution set. So as you can see, we've got a between. We've got 2x plus 5 is bigger than 3 but less than or equal to 15. So we're between 3 and 15. So that's an and. So we want to recognize this as and. And I would strongly recommend you write it using and. So I would do 3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 15. So you could almost think of it as, you've got some parentheses there. So I would write it as and then solve them separately. So I would move negative 5 to the other side. Subtract 5, I guess, if you want to think of it like that. So subtract 5. And we get negative 2 is less than 2x. And we can just divide both sides by 2. And we get negative 1 is less than x, or x is greater than negative 1. Then we got to do the other side. So on the other side, we'll subtract 5 from both sides. and we get 2x is less than or equal to 10. And then we'll divide both sides by 2 and get x is less than or equal to 5. So we get x is greater than -1, and at the same time, x has to be less than or equal to 5. So the solution set would be all x such that, and this is and, so we can write it this way if we want, but most people would write it as x is greater than -1, but less than or equal to 5. So that would be the common. That would be the common way to write that. And then we were asked to graph it, so we just need to show what that looks like on a number line. So we need between -1 and 5. So this is every x value. So let's say this is 0, and then we have 1, 2, 3, 4. 5's not going to fit. Make it a little longer. So 5, and then -1. So we want to be bigger but not equal to -1, and less than or equal to 5. So you can't equal 5, so it'll be a closed dot, and then we want to be between them. So we've got our solution set and a number line showing where all the solutions are. So in other words, if you pick any real number on this part of the number line and plug it in, it'll solve it. So you can't check every single answer because there's an infinite number of numbers you could pick here. But I mean, just to kind of, if this was a test and you wanted to convince yourself that this is probably right, you could just pick one of the numbers in here. So say I pick 2, say I grab 2. So it'd be 3 is less than 2 times 2 plus 5, less than or equal to 15. So that'd be 3 is less than 4 plus 5, which is less than or equal to 15. So 3 is less than 9, which is less than or equal to 15. That's definitely true. So if you wanted to check, you could, I mean, it's not a perfect way to check, but you could pick an answer where you think, on the number line where you think it is, and see if it works. So I tried 2 and it worked. That doesn't mean that my answer is 100% correct, but on a test, I'd feel pretty good about that answer. All right, let's try another one. Okay, this time we will look at a disjunction. So 7 minus 2y is less than or equal to 1, or 3y plus 10 is less than 4 minus y. So we just need one or the other, or both, to be true. But if one or the other is true, we're okay. So just work with them separately. So let's add, let's see, we'll subtract 7 from both sides of the inequality. Get -2y is less than or equal to -6. And then we'll divide both sides by -2. And we get y is greater than or equal to +3. You got to flip that inequality because we divided by a negative, or multiplied by a negative, however you want to think about it. On the other side, let's subtract 10. And we get 3y is less than -6 minus y. And then we will add y to both sides. And we get 4y is less than -6. And then divide by 4. We get y is less than -3/2. So we end up with y is greater than or equal to 3, or y is less than -3/2. So our solution set is just y such that, nothing fancy here, you just write both of them with the word or. Turns out any y value bigger than or equal to 3 or less than -3/2 will work. And then we just need to graph that on a number line. So that's every y value. Let's see, so if this is 0, we'll go, let's have That'd be 0. Then we got -1, -2. And we'll have 1, 2, 3. That should fit. So greater than or equal to 3 would be close dot, shade to the right. Less than -3/2 would be open dot, shade to the left. So this would be what we think our solution is. And again, there's no perfect way to check your answer, but you could pick one of the values in the shaded region and try it. And if it works, I'd feel pretty good about that, especially on a test. So let's say we grab, 4, because that's in the shaded region. Let's try it. So if I plug in 4 to the left inequality, I get 7 minus 8 is less than or equal to 1. I get -1 is less than or equal to 1. And that is true. And that's all we need for a disjunction. I just need one or the other to be true. So again, I don't know that if that makes my solution set 100% correct. I just know that I think this is the solution set, and I tried one possible answer from it, and it worked. So on a test, I'd feel pretty good. So on test, you're timed. So I would just check one and move on.